Okay, now we have our basic climate graph created. It doesn't look like what you'd normally think of as a climate graph. You might see in an atlas or a textbook. The computer has used green bars to represent precipitation and a blue line to represent the temperature curve. The x-axis across the bottom does have our months of the year, representing every second bar on the graph. The left y-axis identifies temperature. We have a range from -7.5 all the way up to 30 degrees. And on the right hand side we have a precipitation range from 0 up to about 80 millimeters. Now if you're handing this in as part of an assignment, you're going to want to change the appearance of the graph slightly to make it look more like a normal climate graph, because some of the information included above on here in the table that we created, we have to add some of this information to the graph to make it more readable and easier to understand. Now the first way we're going to do that is we're going to click on the graph. We're going to make sure the green bars are activated. So we have the bars are shown to be activated because they're highlighted in the table above. And we're going to change those to a blue color. So we're going to go up top to the top of the window, look for the fill column, and we're going to select any one of these blue colors. I'm going to pick this one. Now the second thing we're going to do is we're going to change the blue line representing temperature. We're going to highlight that. We're going to go back up to the top. Change that to a red color, because red is traditionally used to represent the temperature curve. Now we see here we also have these little blue circles are still remaining. I'm actually just going to get rid of those. So we'll click on the graph, click on the circles, go over here to symbol and get rid of the symbol by selecting none. And that will give us a nice smooth temperature curve against the blue bars. Now, our next step, we're going to modify the number of divisions on each of the axes. So if we click on the graph again, see this window in the spreadsheet kind of expands itself, and we're going to pick the left axis first. We're going to increase that from 4 steps up to 6 steps. That will give us a temperature range of 40 degrees. So we'll go from a -10 degree value all the way up to a +30 degree value. We're then going to go over to the second y-axis. We're going to move that from 4 steps up to 10 steps, and we're going to increase the maximum value, maximum precipitation value to 150 millimeters by altering the maximum allowed value. Just hit enter, and then I'll click it. So we now have a range of 0 millimeters all the way up to 150 millimeters. The reason for doing this is it'll allow us to make a comparison with a second graph we're going to make later on in the exercise, which will have, by doing this, both graphs will have the exact same axes. Now we're going to add titles to each of the axes. So we'll start on the left again. We'll go over to the value of x, y1, click show title, and a little title box will appear on the left hand side of the chart. I'm going to click on it once, then double click, maybe, and then we're going to type in there temperature. I'm going to make sure we identify degrees Celsius at the end. So on the right hand axis, we'll go and we'll show title again. I'll just get rid of the text that's there. We'll type in precipitation. I'll make sure to identify that it's being recorded in millimeters. So just put brackets with the mm there. We're also going to change the main title for the chart. Since this is Toronto, we're going to put the name of the city. We'll put the province. And then in brackets, we're going to put 1971 to 2000, because these are the long-term climate normals for the city. So we're almost done. We're just going to go back. We're going to click on the graph again. We're going to go up and move away from the axis tab over to the chart tab. We're going to decrease the amount of space between the bars. So we're underneath where it says bar format, the gap between the bars. We're just going to lower that to say 30%, maybe even 20%, just to give more of a smooth flow and appearance between the bars on the graph. A fifth step, we're just going to go down and change the names in the legend. So our red line is now representing temperature in degrees Celsius, and the blue is representing precipitation. Oops. In millimeters. So there you have it. Your graph is now complete. It's ready to be copied and pasted into a report or a slideshow. Now what I've done is I've gone through the exact same process that we went through to get the data for this and create this climate graph. Except I went through and I picked out an individual year. So for this one we have the climate graph for Toronto for 2005. You can see there's already slight differences compared to the long-term normals. So what we can do is we can actually cut and paste both of those graphs and put them side by side to compare them. So we have the same axes on all three sides. So from 0 to 150 millimeters for precipitation, minus 10 to plus 30 for our temperature graph, and the same 12 months across the bottom of the year. And you can see that we have a little bit of a difference here in the amount of precipitation occurring in May, June, and July. We have much more precipitation occurring in August. The temperature range is slightly greater. It's a little warmer in the summer months, and we actually have kind of a longer warm period during May through kind of into August. It was actually warmer in 2005. We have a similar minimum temperature in January, a similar minimum temperature in December, but we also have less precipitation occurring in several of these months. Now you can go through and create the individual graphs for, say, 1995, 1985, 1975, and compare those to the long-term normals for Toronto. Okay, now that you've created your climate graph for the city of Toronto, you may want to try to create a climate graph for a different city or a different region in Canada to compare it to the city of Toronto. For instance, how does a climate graph for Toronto compare to the cities of Vancouver, Iqaluit, Saskatoon, or Halifax? Or maybe if you want to consider comparing Toronto globally, how does the climate graph for Toronto compare to a climate graph for Cairo or Kuala Lumpur, San Diego, or maybe even Buenos Aires? As you're looking at these climate graphs, here are some questions you may want to consider as you examine and interpret them. Which month is the warmest, or perhaps the coldest? Is there a large or small temperature range at this location? How does the temperature range compare between different locations? When does the majority of rainfall occur? Is there a large difference between summer and winter conditions? And can you find any differences in your climate graphs to indicate differences between the cities in northern and southern hemispheres?